Welcome back, class. So we're going to continue with chapter 2 using ratios, percentages, and proportions. Our topics for this section is just the proportions section. Our learning objectives are to describe the use of ratios and proportions in pharmacy, compute pharmacy calculations by using ratios and proportions, and we're going to compute pharmacy calculations using the ratio proportion method. So proportion is an expression of equality between two ratios. A proportion can be visualized by thinking of two triangles that have the same shape but are different sizes. So an example of a proportion would be this figure. So we have two triangles that are similar, but their ratios are different. So this one's 3:4, but they equal each other. 15 to 20. So if I were to reduce 15 and 20 by 5, I would get 3:4. So their ratios are equivalent. Okay. A proportion is notated by an equal sign or a double colon between the ratios. So the following are examples of ways that a proportion can be written. So again, we have two ratios, this one 3:4, and we have the ratio 15 to 20. And again, the proportion is here, the equal signs. If we have a double colon, like in this example, that's also a proportion. Or using the fractions. So again, ratios can be written in fractions. So this is our ratios, 3 divided by 4, and our proportion would be the equal sign, 15/20. In a proportion, the first and the fourth, or the outermost numbers, are called the extremes. So 3 and 20 are the outermost numbers, are called the extremes. Or if you want to count, this is 1, 2, 3, 4. So 1 and the fourth value is the extreme. The second or third or the inside numbers are the means. So the two numbers closest to the equal signs would be called the means. Okay. How do we how do you call it? How do we check if these two ratios are proportion or equal to each other? We will follow the following steps. So we would multiply the innermost or the means, and that should equal the multiplication of the extreme or the product. Okay, so given a proportion, A to B is equal to C to D, so the products of the means will equal the products of the extreme. So if you multiply the means, B times C has to equal A times D, okay, in order for it to be an equivalent proportion. A ratio proportion method is one of the most frequently used methods for calculating medication dosage in pharmacy. So this method is the one that we will use most, and basically we'll use ratios and proportions whenever we're trying to find the conversion. So if, for example, we have 1 gram is equal to 1,000 milligrams, and if we want to find our answer in milligrams and we have our medication in grams, we need to use that ratio and proportion method to figure out the conversion of that grams to milligrams. Okay. You can use this method anytime one ratio is complete and the other ratio is missing a component. So you basically will have 3 values and you're missing only one value. So in rules for using ratios and proportions, so 3 of the 4 amounts must be known. The numerator must have the same units of measure, and the denominators also have the same units of measure. So like I was saying previously, if you have 1 gram is equal to 1,000 milligrams, and that's your ratio, 1 to 1,000, And then in the other ratio, you want to know how many milligrams are in 2 grams. So then the 1 gram has to be the same numerator. So you would put the 1 grams on the top, and you would put the milligrams in the bottom of the line. So the denominator will be your milligrams. And then you would use the cross multiplication to solve your answer for milligrams. Table 2.3, so these are the steps to solve for x in a ratio and proportion method. So create a proportion by placing the ratios in fraction form and use a variable to represent the unknown value, for example, x. Check that the unit of measure in the numerator is the same as the unit of measure in the denominator. Use the mean extreme properties of proportion to cross multiply and solve for the unknown material. Check your answer by seeing if the product of the means equals the product of the extremes. So you want to check your work. It should equal the same value. The ratio and proportion method can also be used to solve many time of percentage problems. So when setting up the ratios, remember that a percentage may be written into a fraction, and that percentage value over 100. So for example, if we have 95%, we know that that's equivalent as 95 over 100. Okay. So solve for the x for the following ratio. Round your answer to the nearest 100th when necessary. So x over 10 is equal to 20 over x. So we said again to multiply the extremes and multiply the means. So x times 40 equals 40x. 20 times 10 equals 200. Now we would divide by 40. So 200 divided by 40 will give us 5. So x is equal to 5. Okay. So we'll stop here for this section, and we'll move on to the next video, where we will show you how to do some problems from the problem sets. And so see you in the next video. Bye-bye, class.